Hi, this is Mrs. Kidman, and in this video, we are going to be discussing basics of graphing rational functions. So we've talked about rational functions in the past. Rational functions are functions where the variable is found either in the numerator or the denominator or both, right? So typically, the most basic rational function that we see is 1 over x, right? That's going to be our most basic, our parent function of all of them. So a rational function is one where it has that variable in the top or in the bottom. So we can see something like 3x plus 4 over 2x, we could have something like 1 over x. We could have something, theoretically, your polynomial function could be written as a rational function, but why make it more complicated than it is? Okay, let's take a look at the parent function. So the parent function of a rational is 1 over x. That's a parent function is considered the most basic of all types of functions. So every other rational function is based off of this one, especially when it comes to those shifts. So what happens is when we look at it, you can kind of see this curve that it creates. Now with parent functions and with not parent functions, with rational functions, we end up seeing something called an asymptote. An asymptote is this barrier that's created that the function never actually touches. We say that it approaches it. Now, in rare cases, there are some types of asymptotes that functions do actually touch and cross. However, for all the ones that we're going to be studying, they are going to be ones that are these barriers that the function never crosses. So what we want to do is we want to take into account where those are. Now, there are two different types of asymptotes. We have what are called vertical asymptotes. So you will often see those. So vertical asymptotes. Those are the ones that are created with a vertical line. So we can see here on our graph that we have a vertical asymptote at x equals 0. Do you see how our function approaches that line, but it never actually touches it? We also have a type of function called a horizontal asymptote. And a horizontal asymptote is just going to be a horizontal line that the function approaches but never reaches. So these vertical asymptotes are related to our x values. The horizontal ones are related to our y values. So we can kind of see this dashed line that we draw in there. Anytime we draw an asymptote, we want to use a dashed line to represent that it's not a real line, but it is a line that we care about there. Now, when it comes to our domain and range of these functions, our domain and range are going to be everything except for where those asymptotes lie. Now, there are a couple different ways that we can write that. You're going to end up seeing some notation that we use called interval notation. So sometimes you'll see interval notation that says it goes from negative infinity up to 0 and from 0 to infinity, right? Sometimes people have a union in between those saying that it's this interval plus this interval. That is totally one way to do it. Other times you see it, you might see something like all the real numbers except the number 0, right? Something like that. Other times you'll see something when it's domain, it'll say x is everything but 0. So x can't be 0, but can be anything else. Same thing happens with our range. You'll see similar intervals there. They will look like this. They will look like this. The only other time is you'll see this y is not equal to 0. Now, these both have zeros here, but technically the range is going to be y is everything except our horizontal asymptote with some special cases. And our domain is going to be x is everything except our vertical asymptote. So we're going to talk a little bit about how we can shift these functions and what each thing does. So taking a look right here, if we wanted to compare the graphs of these two functions, what do you notice are the same and what do you notice are different? So as we look at these two graphs, some of the things that you might notice are the same is they are in the same quadrants, right? They both are located in 1 and 3. We can draw this asymptote here on both of them, this vertical one at 0 and this horizontal one at 1. So they have the same vertical, asymptote and the same horizontal asymptote, right? Things like that. Now, what's different? We can talk about the sharpness of our curve as being a little different. And notice how the bigger this number is, the less sharp our curve is. Now, the way that I like to relate that is to the real world. Think of it if you can drive. So if you can drive a car and you are driving really quickly, say you're going the freeway, right? If you go and take a corner, it's going to be kind of a wide corner. However, if you're driving in town and you have to go make a right-hand turn, you basically have to slow down to a stop before you can make that right-hand turn. The tighter the corner we have to make, the slower we have to go. So if you think of this number on top, like our speed, if I am driving at 4 units per measure, it's going to be a lot less steep of a curve, so a lot wider of a curve than if I'm driving at 1 unit per box there, things like that. So as we're looking at those, we can see that sometimes they will increase and sometimes they'll decrease depending on what that A is. Now, what I want you guys to do is work with your graphing calculator and the people next to you to compare the graphs of these two. Now, as a quick reminder, if you are graphing, you can pull up your graphing calculator as you need to and type that into your y equals function there. So make sure that you know how to do that if you need that. If you have a question, don't hesitate to ask. So as we go to sketch a picture of this graph here, you'll graph them both in your calculator. And what will you notice? Well, you may notice something like our 1 over x is still right here and right here. It's not exact. This is a sketch. Our negative 6x is going to be over here, and it's going to be a lot broader of a curve, right? We're going to see something like this. Now, it might not be exactly to that extreme there, but you can kind of notice what it is. So what are the same? Well, they still have the same vertical asymptote, which is often abbreviated like this. They still have the same horizontal asymptote, right? So those barrier lines that kind of prevent it from going somewhere else, they both have that. Now, what's different? They ended up in opposite quadrants, and their sharpness or their steepness of that curve is going to be a little bit different. Now, why do you think we get this opposite quadrants on this one, but not on the other one? It's going to come from that negative part on our 6 there. That negative is what allows it to flip those quadrants. Now, what we're going to do is we're going to end up talking about how do all the shifts or transformations of these functions affect each other. Now, we kind of explored what a does, right? So the bigger the a gets, the less tight the curve, which means the smaller the a gets, the tighter the curve. So let's talk about these transformations here. So looking at a has 2 pieces. If a is positive, then what's going to happen is we are going to see it in quadrants 1 and 3. We're going to see a picture like this. When a is negative, we're going to see it in quadrants 2 and 4. They're going to be over here. It's just going to reflect. Okay, so this motion here means that we are going to reflect across the x-axis is what happens here. So it reflects across the x-axis. It gets flipped down wherever it was at. The other piece that we see comes from what the value of a is. So if the absolute value of a is bigger than 1, meaning that we have a -7 or positive 15, whatever it is, we are going to have what's called a vertical stretch. Now, a vertical stretch means that our function is going to be further away from the curve. So as you look here at this one, that distance of our curve right here at 3 going from here to here is shorter than that distance from here to here on our axis there. So because that distance is changed, it's stretched away. That's called our vertical stretch. Now, when our absolute value of a is between 0 and 1, so you see a 1/3, a -2/7, things like that, what we get is a vertical shrink. And that vertical shrink that we see causes it to get closer to the x-axis. So that's kind of what happens there. Now we have 2 other pieces here. We have our h and our k. Now our x minus h, you'll start learning with functions that always controls our left and right shift. So when we see plus a number, that means we are shifting to the left. When we see minus a number, we are shifting to the right. Okay, what this h also ends up telling us is it also tells us our vertical asymptote. The reason why is if our asymptote's typically at 0, 0, and our whole function gets shifted to the left 2, our new asymptote also gets shifted to the left 2, and it puts it at that -2 there. If it gets shifted to the right 7, our vertical asymptote is also shifted to the right 7, and it moves from there. Our last piece that we have here is our k. Now, our k controls our up or down. So if we have plus a number on the end, we're going to go up. If we have minus a number on the end, we're going to go down. And our up and down shifts there, that vertical shift, ends up controlling our horizontal asymptote. Because typically if it's at 0 and we shift it up, then it's going to take that horizontal asymptote from 0 up. If we take it and shift it down, the horizontal asymptote is going to go down along with it. So we kind of see how those work. Now, how these relate to our domain and range. Our domain is going to be everything except our vertical asymptote. So x cannot be our vertical asymptote, whatever that number is. Or you can write it as -infinity, whatever our vertical asymptote is. And from our vertical asymptote to infinity, you'll kind of see it written either of these 2 ways. The same thing happens with our range, but our range is our y values. So y cannot be our horizontal asymptote, or it's going to be -infinity to our horizontal asymptote and our horizontal asymptote to infinity. Now let's go ahead and sketch a picture of these graphs with what we have here. Before we do that though, we are going to practice our shifts. So how does this function shift here? So looking at our first one, this 3 is going to cause a stretch. Which quadrants is it going to be in? 1 and 3, because we know that it's positive. This is going to shift to the left 1 it's also going to go up too. So what does that mean about our function? Well, let's talk about where our vertical asymptote is going to be, where our horizontal asymptote is going to be, where our domain is going to be, and where our range is going to be. So our vertical asymptote is related to this left one. So we're going to get an x equals -1. It's an equation of a line, right? We have this line at x equals -1. Our horizontal asymptote is also a line, but it's a horizontal line. So it's y equals 2. Now to find our domain and range here, remember, we're going to do our x is anything but this. So we're going to see this x cannot be -1. Or you might see -infinity to -1 and -1 to infinity, because our domain relates to our vertical asymptote. Our range relates to our horizontal asymptote, so y is anything but 2. Or it goes from -infinity to 2 and from 2 to infinity, as you can kind of see there. So that's how that one shifts. Let's take a look at this next one over here and compare those. So this 6 here does two things. We are going to get that vertical stretch. The negative piece is going to cause it to reflect across that x-axis there. So we are going to see that shift as it gets flipped over. Our +4 is going to cause it to go to the left 4. This -7 is going to cause it to go down 7. So how does that relate to our pieces? Well, our vertical asymptote, our horizontal asymptote, our domain, and our range. Our vertical asymptote is going to be at x equals -4. Our horizontal asymptote is going to be at y equals -7. Our domain, remember, we can write that one of two ways. We can either say x is not -4, or you can say -infinity to -4, -4 to infinity. For our range, it's going to relate to that y value. So we can either say y is not -7, or it's going to be everything up to -7 and everything after -7. That's what both of these things mean. So those mean the same thing. It can go either way. Now that we have that, let's actually start sketching a graph of these. Now, the cool thing is we are not actually graphing here. We are sketching the graph. So everything you do, you want it to be a sketch. So first we want to describe the transformations. Then we want to find our asymptotes. Then we want to sketch the graph from what we have, and last state our domain and range. So let's take a look at this. How does our function shift here? The 1 causes no stretch. We went to the left 2, and we went down 3. So how does that affect our asymptotes? So we have our vertical asymptote, our horizontal asymptote, our domain, and our range. Now our vertical asymptote here is going to be affected by that left 2. So now all of a sudden we are going to see this x equals -2. Our horizontal asymptote is reflected by our shift up and down. So we've got this y equals -3. Now, how does that impact our graph here? So on my graph, when I go to graph it, I have this line at x equals -2. I have this asymptote at y equals -3. Now, did my function get reflected? The answer is no. So because it doesn't get reflected, we know it's going to be in quadrants 1 and 3. And this is a sketch. So that 1 means that it's going to be kind of a tight curve. So we're going to see something that looks like this. Notice how this is not perfect there. You are just sketching a picture of it. So then what would our domain and range be? Well, our domain would be x can't be -2, or it's -infinity to -2 and -2 to infinity. Our range is going to be y cannot be -3, or you can write it as -infinity to -3 and -3 up to infinity. Either of those two methods work there. But that's how we can do all 4 of those pieces. So it's not super tricky. We just want to identify those things and decide which quadrants and how sharp they need to be. So let's take a look at 2 more examples here and kind of see how this goes. So we're going to take a look at our -3 here. This one is going to both stretch, and this negative means that we are going to reflect. This has no horizontal shifts, no horizontal shifts, but it does have a vertical shift of up 1. So how does that affect it? So our vertical asymptote is going to be any of those left and right shifts, which we don't have any, so it's still going to be at 0. Our horizontal asymptote is going to be any up and down shifts, so that's going to be at 1. Then we can find our domain and our range from there. So as we find our domain, that's going to be anything except 0, or -infinity to 0 and 0 to infinity. Our range is going to be y can't be 1, or it's going to go -infinity to 1 and 1 to infinity. Either of those 2 methods will work out fantastic. So let's actually sketch our graph now. So we have our vertical asymptote here at 0. We've got our horizontal one here at 1. We know it gets stretched, so it's going to be kind of a gentle curve, and it gets reflected. So we're going to see something that looks like this. Beautiful. Okay, one last time before we move on. So the last thing we're going to look at is the same thing. So how does this one shift? Well, this one stretches. This one moves to the right 2, and it goes up 3. So let's talk about those different pieces there. Our vertical asymptote is going to be at x equals 2. Our horizontal asymptote is going to be at y equals 3. Our domain and our range are those last pieces there. When we go to find those, our domain is going to be x can't be 2 or negative infinity to 2 and 2 to infinity, right? It can be any value but those ones. And when you guys think about it, think of this. If I put 2 in here, what is 2 minus 2? 0, right? That's why it can't be that value. That's why we get that asymptote there. That shift of 3 is related in that similar way of we end up finding out that we can never get 3 as a value. Our range shows us that our y output can never be 3. So we're going to end up getting a negative infinity to 3 and a 3 to infinity sort piece there. So let's take a moment to sketch this last graph. So we have a vertical one here at 2. We have a horizontal asymptote at 3. It didn't reflect, so it's still going to be in quadrants 1 and 3. That's kind of created here. And that 2 means it's going to stretch a little bit. So we're going to see something that looks kind of like this and something that looks kind of like this. Now, you're welcome to sketch it in your graphing calculator if you want to double check, but make sure you know how to do it by hand, because when you all go on to take calculus later, you will need to know how to sketch these by hand. But that's how you can graph basic rational functions based on their transformations. If you have any questions, don't hesitate to reach out.